Hi, I'm here to discuss to you another video, this time about spanning tree. So let's begin. So what is spanning tree? Spanning tree protocol prevents loops from being formed when switches or bridges are interconnected by multiple paths. Spanning tree protocol implements the 802.1d IEEE algorithm by exchanging BPDU messages with other switches to detect loops, and then removes the loop by shutting down the selected bridge interfaces. This algorithm guarantees that there is one and only one active path between two devices or network devices. So in our lab today, we're gonna have four switches. This is a diagram for it. Um, Before we begin, let's answer some questions regarding spanning tree. So, what type of frame does STP use to communicate with other switches? The answer to that is BPDUs or bridge data units or bridge protocol data units. And what command do we use to um, determine the spanning tree? So let's log into it. I already pre-log into those switches. So the command for that is it's as simple as show spanning tree. So in this command, you can see two sections. One is for the root ID, which gives you the properties for the root, and the bridge ID, which gives you the properties for the current switch that you have. It's very important to differentiate the two of them because, as I'm gonna show you later on, the root ID would have the same properties because that switch is the root. So if you do it on the other switches, show spanning tree. So important to take note also that um, the root switch could be identified using, like what I said, the root ID on the spanning tree, show spanning tree command. And the root switch or a switch is selected as the root if it has the lowest MAC address. So if you compare the MAC address for switch 4 with the MAC address of the root bridge, as you could clearly see, the difference is this one has a larger um, MAC address number. So that is why the the problem with spanning tree is if you have an older switch, most likely it will be selected as the spanning tree root because it has a lower MAC address number. So that's why they come up with the priority in which you could arbitrarily select which priority you want for a particular switch in order for you to influence um, it being a root or not. So there are different roles in a spanning tree port. There is the designated port, the root port, and the alternate or the blocking port. So as you can see here, so the designated port. Oh, by the way, we only have one VLAN that I configure here, which is VLAN 1. So what causes a port to be in blocking state over another? So the answer to that is all ports priority facing the root are the same. Well, when all the ports priorities are when all the port priorities facing the root are the same, it would always choose the lowest interface number. And um, when one link is blocked over another, um, what causes that um selection is when all the ports priorities facing the root are the same, the lowest interface number is chosen. In addition, a switch with more preferred, let's say lower priority, are likely to be a transit switch, even if they are not root switches. So going back to the lab that we have, so you might ask, why is it that you're saying that if they have the same priority, why is it that switch 4 has all its ports forwarding, whereas switch 3 has one blocking port? I thought that the the span tree always chooses, if it has the same priority, it always chooses the lowest uh, MAC address number, which in fact this one clearly is not. The reason for that is if you look at the cost to get to the bridge, this one, switch 3, has a bigger cost than switch 4. Or even if you're not looking at that, if you knew the root bridge by just looking at the diagram, you could clearly see that it's not going to block any ports on switch 4 because it's nearer to the root. Whereas for switch 3, it's much more farther. And another command that is useful to determine the root is show spanning tree root. So maybe we could do a question mark first to see the commands. So as you can see here, it clearly shows if you put root, it will show you the status and the configuration of the root bridge. So from there, it will give you the root ID number and what VLAN is he a root on and the cost to get there and the port to get there. So which is if you compare it here, since this one is blocking, which is correct one here. So the logical way to go to the root is through the port on internet slash 01. And also another reason why they block this port is because switch 2 is more preferred because if you compare switch 2 with switch 4, the rules on the span tree would be the same. It chooses the lowest MAC address number. And that's about it for spanning tree. Later on, we're gonna discuss about more in depth about the different kinds of spanning tree, and also we're gonna discuss on another video about another routing protocol, RIP. No, not RIP. EIGRP and OSPF, and also um, learning how to make your router as a DHCP or DNS server. Thanks, guys, and hopefully you subscribe. And if you have any comments, please put it on the YouTube channel. Thank you.